Hello everyone, so today I'll be discussing question number 57 and 58 of GATE 2009. In the cantilever beam PQR shown in the figure, the segment PQ has flexural rigidity EI and the segment QR has infinite flexural rigidity. So here we have a cantilever beam in which segment PQ has EI flexural rigidity while the segment QR is infinitely rigid, both having length L. So here two questions are linked. Question number 57 says the deflection and slope of the beam at Q are respectively. So four options are given to us and it's a 2-mark question. We have another question, question number 58, which is linked to this problem, which says the deflection of beam at R is. So here also four options are given to us and it's a 2-mark question. For this type of questions, you can refer to lecture series on engineering mechanics by Professor K. Ramesh, Department of Applied Mechanics, IIT Madras. Let's proceed with the solution of this problem. Let us first try to make the possible deflected shape of this cantilever beam under this load W. So this beam will deflect like this. It will be curved till point Q, and after that, since this portion is rigid, so it will go as a straight line. It will not bend. So it will be curved for portion PQ and it will go as a straight line after that. So this is the possible deflected shape of this beam. Let us call this as theta. Therefore this will also be theta. Let's call this deflection as delta Q. This will also be delta Q. Let's call this part as delta R dash. From this we can say that delta R will be delta Q plus delta R dash. So in order to find the deflection at point R, we need to find delta Q and delta R dash. So let's start by finding out the value of delta Q. So here I'll make this cantilever beam again. So this portion of this cantilever beam is rigid. In order to find the value of delta Q, we need to shift this load W at point Q. So we'll shift this load W at point Q here. So it will be W, but when we shift the load, there will be a moment also. So the moment will be, and the magnitude of that moment will be W multiplied by this length. So it is W multiplied by the length with which we have shifted the load. Okay, so it is point load W plus this moment WL. So now we have all the loads. Let us again make the deflected shape for this cantilever beam. So it will be curved till this point and will go straight. Okay, now this is theta and this is delta Q. Here this delta Q is due to this point load and this moment. Therefore from standard deflection formula, the value of delta Q will be PL cube by 3EI, that is the deflection due to point load, plus ML square by 2EI, that is the deflection due to moment. So the value of delta Q we will write it as, here the load P is W, the length of this portion is L, so L cube divided by 3 times the flexural rigidity of the beam, plus what is the value of moment? Moment is WL multiplied by length square divided by 2 times the flexural rigidity. Delta Q will be 5WL cube by 6EI. Now we have calculated the value of delta Q. We will now calculate the value of theta Q. So theta Q will be PL square by 2EI plus ML by EI. That is theta due to point load and theta due to moment. Theta Q will be, here the P is WL square by 2EI plus value of moment is WL into L EI. Therefore, theta Q will be 3WL square by 2EI. Now we know that delta R dash, which is this value, will be equal to theta Q multiplied by this length, which is L. Therefore, we will calculate delta R dash as theta Q multiplied by L. So delta R dash will be, theta Q was 3WL square by 2EI multiplied by L, and therefore delta R dash will be equal to 3WL L cube by 2EI. So we have now calculated the value of delta R dash as well. So finally delta R will be delta Q plus delta R dash. So delta Q is 5 by 6 WL cube by 6EI and delta R dash is 3 by 2 WL cube by 2EI. So we will calculate the final value of delta R as delta Q plus delta R dash. So delta R will be, delta Q was 5 by 6 WL cube by EI and delta R dash is 3 by 2 WL cube by EI. So finally our value of delta R dash will be WL cube by EI, and which comes out to be delta R will be 14 WL cube by 6 EI, which we can further simplify as 7 by 3. So delta R final value will be 7 WL cube by 3 EI. So this is matching with option number B. So this was the answer for question number 58. Question number 57 was linked with it, and in between we have calculated the value of delta Q, that is a deflection at Q, and slope at Q also. So deflection at Q we calculated as 5 WL cube by 6 EI, and slope we calculated as 3 WL square by 2 EI. So let's see which option is matching. So 5 by 6 WL cube by 6 EI and 3 by 2 WL square by EI. So option number A is matching. So finally the answer for question number 57 is A option, and for 58 is option number B.